David. David. This boy, eh? Out. Get out from there. It's clean. It's miracle. Why is sleeping like this?
I'm going to call you because man, no.
Dayo. Only the episode. Class together.
Airport.
No airport.
Airport.
Yes, you are no, mom.
That one is the last. Just put it in your ear. That one that you put in your after that is one that is sounding very like this. That be like a tick. That's why I'm mine.
Mo need the way. Where am I? Let's me be back.
Let's see. Let's see.
Okay, my love.
Good evening, ma.
Kamu where so mo se be back. Then go.
Good evening, ma. Mrs. Popola, please kindly mute your mic.
Hey, sorry.
The lecturer is online with us.
Hello, good evening, everyone.
Good evening, ma. You are welcome, ma.
Yeah.
Good evening, ma.
Welcome.
I hope our day was fine.
Very well, ma.
Okay, let's go back to the class. This night thing, I will try. After the stress of the day, I always prefer morning class, Jam. But let's see how far we can go with this. God will help me. I had a very long day. Can you summon to take the class? Adebanjo, are you talking or you're muted yourself unconsciously? I want to know introduction. My name is Dr. Anita. Okay, I'm a lecturer of chemistry. My area of specialty is natural products. That is what I'm passionate about. So I'll be organic chemistry lecturer for the course. Okay. So the course Can you hear me? I
Yes,
don't
ma, we
understand.
can
No.
hear you.
Why
Yes,
why you
ma, we
guys not
can.
responding now?
We are just
We are
hearing you
actually
now,
muted
ma.
before.
It
We
went
just
off
started
before.
hearing your voice.
It
Just
went off before.
okay. Okay. Now, because I'm trying to confirm this mic. Can you hear me now?
Yes, ma, we can hear
Yes,
you.
ma. Yes, ma.
Can you hear me?
Yes, we can.
So is it that there was a time you were not hearing me because I wanted to test the mic?
Yes,
Yes,
ma.
there was time we were not hearing you.
Okay, maybe the mic is not working. So let's go. So somebody should take the floor. I need introduction. Did you hear me when I did my own introduction?
Yes, ma, we have you.
Okay, so let's know ourselves. I want to meet you.
One after the other, please.
Giwa, take the floor.
Okay. My name is Giwa Ibrahim Abidemi, studying STEM education and entrepreneurial biology aspects, ma.
Okay, your background. Your background. Are you science background, chemistry background? Your secondary school, do you have chemistry? Did you do chemistry in secondary school?
Yes, ma.
Okay,
I did all the science things.
okay, fine. Alhaji
Yes,
Abu.
ma.
Yes, ma.
Giwa, where are you
I
from?
am Alaha.
I'm from Lagos State, ma.
Okay,
Yes, ma. I am Alhaji Abu Kamara. Master's STEM education in chemistry from Sierra Leone.
okay. Alhaji, you're welcome to Nigeria. I hope you're enjoying yourself in Nigeria, or are you joining online?
Yeah, I'm online. We're preparing to travel,
Okay,
traveling
so
in July by God's
so when you're coming down, make sure you bring something from Sierra Leone. If you come empty-handed, Alhaji will kidnap you.
power.
Okay. Oh yeah. Omobolanle. Who is talking? Is it Charles Benedict?
No, I'm not talking. I'm not talking, ma.
Oh yeah, talk. You guys are wasting our time. Do introduction. Are you shy of introduction? Are you phone shy or are you?
Good evening, ma.
Myself, sorry,
evening,
ma.
ma.
I joined late, so I didn't know we are on.
Good evening, ma.
Okay, yeah. Just introduce yourself.
Yeah, I'm Augustine Fona from Sierra Leone.
Okay.
MSc STEM education in mathematics.
Any background in chemistry?
Yes, I did chemistry in my secondary school
Okay,
down
good.
to WAEC. I took chemistry in the WAEC exams.
Okay, that's a good one.
Yes, ma'am.
So
Okay,
I am Charles Benedict Noah from Sierra
okay,
Leone, MSc STEM in education biology.
okay. Chemistry background.
Yes, chemistry, but
Okay, good.
yes.
Let's continue. Let's begin. Kura.
Not my birthday either. Hello.
Say welcome. Oh, are you in Nigeria?
No, I'm not a Nigerian. Sorry, I'm a Sierra Leonean. I am a Sierra Leonean.
Are you in Nigeria? Okay, you're joining online.
Yes, I'm joining online. I'm currently in Sierra Leone.
Okay, Charles, fine.
Hello.
Yes, ma'am.
Next,
Popola.
Awoshe Shemako. Well, I no bite my tongue. Oh yeah, introduce.
Semako, introduce yourself. Semako.
Why are you guys shy to introduce yourselves? So I don't know.
Good evening, Ma. Good evening, Ma. Good evening, everyone. My name is Maria Oluwafumila Diayitigbo. I'm from Nigeria. MSc STEM Education Biology option. I have a first degree in microbiology from IFE and a PGD from University of Lagos. I'm from Ogun
Wow,
State. Thank you.
great acokites.
Great.
Nice. Okay. Next.
Good evening.
Yeah, good evening.
My name is Shakira Debisi. Good evening, ma'am. My name is Shakira Debisi.
Good evening, Shakira.
Yes, ma'am. Masters in STEM Education Biology from University of Lagos. I did
Great acokites.
Great acokites, ma. Good evening, ma. Yes, ma'am. I did included science education in University of Lagos. So I have little of chemistry too.
Okay, good. So nice.
Yes,
Next.
Hello, good evening, Ma.
Good evening.
Emmanuel. I'm from Oyo State. I'm currently undergoing MSc STEM Education and Entrepreneurship in biology option, and my background was biology education from Lagos State University.
Did you say you finished from which school?
Lagos State University.
Okay, you're still in your school.
Yes.
Okay, well done. All right, next one.
Hello, good evening, Ma.
Good evening, Popola.
Yes, Popola Luakemi Naomi. I studied STEM education and entrepreneurship chemistry option. I studied in chemistry.
So you're a chemist?
Yes, ma'am.
Interesting.
I studied industrial chemistry at the University of Lagos.
Wow, great kites. That's nice. Your brain now. Are you Elena?
I'm a
That's
teacher.
a nice one.
Yeah. Then my PGD now, National Open University. My PGD.
Wow, that's interesting. Well done, Oluwakemi.
Yes, ma. I'm from Lagos State.
Wow. So you're Omweko?
Omweko, yes, completely. No, Sierra Leone by birth.
Are you for real?
Yes.
Hey. Where are you now?
I'm in Lagos. I've always been in Lagos.
Okay, wow. Interesting.
Thank you, ma'am.
Next one. Next person.
Good evening.
Good evening, ma'am. I am Abam Solomon. Abam Solomon. Ma, I studied my first degree in Ekiti State University in computer science education, and my second degree in LASU, computer education, and now I'm into PhD artificial intelligence in LASU right now.
That's serious matter. You be a fico, you like book too much. Welcome.
Thank you,
All right,
ma.
next person.
Good evening,
next
ma.
person. Good evening.
Good evening, ma. I am John Nosiru Ogechi Joy.
Your name is complex name, Ogechi. Okay,
yes,
continue.
BSc Education, Computer, UNN. Then presently
be my sister.
Now, so well done, ma.
You're welcome.
Thank
so
you.
Next.
Good evening, ma.
Good evening.
My name is Avonse Semaku Sefremi from Nigeria.
Hi, this name, you're not in Nigeria. It's not possible.
I'm a Nigerian, ma.
It's not possible. This one is speaking in tongues. Yeah, where are you from? My voice, Sheshe, came here. Hey, I'm speaking in tongues.
So I had my first degree in Lagos State University, mathematics
Okay.
education. I'm currently undergoing my STEM education and entrepreneurship mathematics option. Thank you, ma.
Your brain is scatter for mathematics. No wonder your name is speaking in tongues. You're welcome.
Yes, ma.
Next person.
Good evening, ma.
Good evening.
My name is
Ibrahim.
Yes, my name is Ibrahim Jami. STEM education in ICT, cybersecurity option. I study computer science education from Lagos State University.
Okay. So you're still at home?
Yeah.
Well done. Next person.
Good evening, ma. My name is Adeni Shukura Opeyemi.
Okay.
I studied physics education from UNN. Now I'm currently undergoing MSc STEM and Entrepreneurship Education physics option.
Okay. Anybody that knows physics will be good in chemistry, so no cause for alarm.
Yes, sir.
You're welcome.
Thank you, ma.
Good
evening.
Good evening, ma'am. Good evening, everyone. Yes, I am Nuta Yogechi Evidence. Had my first degree in Delta State University, Botany, and then a professional diploma in education in Lagos State University of Education. And I'm currently undergoing my master's in STEM education entrepreneurship biology aspects.
And I can see the evidence already. Ogechi, welcome.
Thank you, ma.
Ogechi, where are you from?
I'm from Anambra State, but I'm married to a Lagos State man.
Because that your surname is all the confused.
God is
All right, next person.
Good evening, ma.
Good evening, Kike Lomo.
Yes, ma. I am Kike Lomo Zanu. I got my first degree from University of Ibadan, mathematics education. And now I am doing my master's in STEM education, mathematics option.
My equation, they fly for your brain, no be small. Well done.
Thank you, ma.
Good evening, ma.
Good evening.
My name is Abdurazak Kairat Burahachi.
Okay.
I had my first degree in University of Ilorin, chemistry education.
Okay.
And I'm currently doing my master's in STEM education and entrepreneurship chemistry.
I can see there are plenty of chemists. All right. Interesting. You're welcome. We're going to dig chemistry.
Good evening, ma.
Good evening.
Yes, ma. Sorry. My name is Shulamite Aremo, and I studied
Shulamite woman?
Yes, ma. Yes, ma. So I studied chemistry and education from University of Ibadan, the first and the best. And
as in it's only Unilag and others, so don't say that.
Ma, Premier University. We don't like it.
All right, continue.
So I'm currently doing my master's in STEM education and entrepreneurship chemistry option. Yes, thank you.
Oh, well, I will go dig chemistry, nothing doing.
Thank you, ma.
Next person. Are we all done?
Ma, can you permit me to reintroduce
Good evening,
myself?
ma.
Who wants to reintroduce?
Good evening, ma. Good evening, ma.
Good evening.
I am Omobolale Kuku.
Okay.
I'm sorry, ma. I am currently on PhD STEM education and entrepreneurship program, chemistry option.
Okay, no worries.
I have a master's in chemistry education too.
No worries. I know nothing to you. We did.
Okay, thank you very much, ma.
Yeah. Next person.
Good evening, Ma. My name is Odiana Vera. I had my first degree in University of Lagos. I studied chemistry
Great
education.
Akokite.
Great.
Do you know me? When did you
I
graduate?
should, Ma. 2008.
Do you know me?
I don't know. But I know Mrs. Professor Fashino.
Fashino.
And yes, Professor Ogunlesi.
Okay.
Yes. Yes.
Then 2008, I was finishing my master's. Fine. Continue.
Okay, Ma. Okay, Ma. So currently doing my master's in STEM education and entrepreneurship in chemistry.
Wow.
Yes, Ma.
You are home.
Yes,
Fine.
so thank you, Ma.
Welcome. Adebanjo was you.
Good evening. Good evening, Ma.
Yeah, good evening, Adebanjo. I can hear you. Go ahead.
Serving Abuja.
Okay.
Are you with me, Ma?
Yes, I can hear you now.
Presently serving Abuja. I had my MSc at Africa Center of Excellence, and I'm doing my PhD in cybersecurity.
Okay. You're welcome. Adebanjo was you.
Good evening, Ma.
Good evening.
Yes, I think I've introduced myself shortly,
Before.
but let me take this opportunity to also share my academic background. I think I didn't do that. I am Charles once more, a Sierra Leonean, but I actually studied, did my first degree at the University of Makerere in Sierra Leone, in Bachelor of Science Honors in Public Health Laboratory, and then later to the School of Clinical Sciences, where I did Advanced Diploma in Clinical Medicine, and then later a Bachelor of Science Honors in Clinical Medicine at the University of Sierra Leone, and later a postgraduate diploma in health.
Charles, you don't do. You do.
Don't do. Okay.
You do.
Now, yeah.
My brain cannot do that. It's too much. The born you bumble. You too read, though. You too read, I beg. Welcome. If you go, we go dig chemistry. We go dig.
Oh yeah, Ma. Another Akokite is here.
Oh yeah. Let's hear you.
All right. Once again, Giwa Ibrahim Abidemi. I had my first degree in biological sciences and education from Taishu University of Education. My master's degree from University of Lagos.
Wow.
Then I'm presently running a PhD in STEM education and entrepreneur biology aspects.
Okay. Your master's was in what? In biology?
Yes, ma'am.
Education.
Yes, ma'am.
You too read, though. Great Akokites.
Great,
sure. You're welcome. You're home.
Thank you.
Who else? Are we all done?
Good evening, Ma.
Good evening.
My name is
Abosede.
Abosede. Yes, Ma. I had my first degree at Ekiti State University, chemistry education, presently on entrepreneurship under chemistry too.
Wow, chemistry. Fine. I think I'm impressed. Almost everybody here has science background. So let's hear Zenab. Grillo, have you introduced yourself?
Good evening, ma'am. I'm sorry. I'm Zainab Grillo, MSc STEM Education Biology, STEM and Entrepreneurship Biology.
Okay. Your BSc?
BSc Cell Biology and Genetics.
From?
University of Lagos.
I can see, because that's the only school I know that does that. It means that you're very good in 213. You did your 213 very well, or 203. Nothing do you. Basic organic chemistry.
Yes, ma'am. Yes, ma'am.
Sure. Great Akokite.
Great. Thank you, ma'am.
Yeah, welcome. Who else? So we can go into the business of the day.
Good evening, ma'am.
Good evening.
I'm Folami Oluwatomilola. I had my first degree at the Ekiti State University. It used to be UNAD, but now it's EXU. I studied biochemistry. I have a master's in educational administration and planning. And now I'm running a master's in STEM education and entrepreneurship with biology specialty, ma'am.
Aye. People where they are, if una too like book, Jesus. Hey, this set tonight will be a fickle pass. You're welcome.
Thank you, ma'am.
Welcome. So who else is there to introduce? Augustine, have I heard from you today?
Yes, ma. I have initially introduced myself.
Okay.
From Sierra Leone.
So everybody have done. I've assumed that we all have introduced. Okay. Nice. I'm very much impressed that if not 100%, it will be 97 or 98% of us here have some basic knowledge of chemistry. So what I'm going to say tonight is not going to be strange. Okay, so once again, you're welcome to organic section of the STEM course. Okay, so I want to go by going to the basis of organic chemistry, just to refresh our mind, because most of us did not just graduate. Okay, and most of us don't like chemistry when they were during their first degree. So that everybody will be on the same page. Okay, organic chemistry. Now, introduction. What is really the organic chemistry? So when we talk about organic chemistry, simply talk about chemistry of carbon and hydrogen. Okay, then with other elements like oxygen, nitrogen, sulfur, and halogen. So when you talk about hydrocarbon, means hydrogen and carbon. Okay, but beyond hydrocarbon are organic chemistry. So organic chemistry is beyond hydrocarbon because carboxylic acid is not a hydrocarbon. So hydrocarbon are alkane, and alkyne because they contain only carbon and hydrogen. That's why they are called hydrocarbons. And there's something about carbon. This carbon, they have an ability to bond with each themselves. Okay? This unique ability of bonding with itself is called catenation. So catenation simply means the capacity that carbon has to bond with itself. Okay, forming a long chain. That's why we can have a carbon that has like 20 carbon skeleton. Okay, so that's what we talk about catenation. So you should understand what is catenation. When carbon bond with itself, we call it catenation. Hope this slide is understood. So we talk about atomic orbital. Remember when we were talking about organic chemistry, we are studying chemistry of carbon first, with other things added to it. Chemistry is the basic compound we are studying in organic chemistry. So whenever you're dealing with any organic compound, any compound that does not contain carbon is not an organic compound. So every organic compound must contain carbon. That's why they're organic compound. Now, talking about the atomic orbital, carbon has 6 electrons in the atom's shell. And what is the atomic number of carbon? The atomic number of carbon has to do with its own electron in the atom's shell. So these 6 electrons in atom's shell. Now, when we are talking about that, the atomic number of carbon, 1s2, 2s2, and 2p2. Okay? Now, when we divide these atoms, electron, into their atomic orbitals, we are going to form 4 atomic orbitals. We have s orbitals, we have p orbitals, we have d and f orbitals. So these are atomic orbitals that we have generally, but in carbon, everybody should be muted. But in carbon, the only atomic orbital among all the 4 types of atomic orbital we have is s and p. Okay, x and p because of the electrons that is in carbon. So we cannot go beyond s and p. Now, s orbital has 2 electrons in the outermost shell, while p has maximum of 6 electrons. So most organic compounds fall within this s and p. But when you get the inorganic compounds, you talk about up to f. Okay? But in organic chemistry, most organic compounds end in 6. Now, talking about atomic number of carbon, which is 6, if I want to talk about the electronic configuration, remember S has maximum of 2. And we have the first energy level is 1, second energy level is 2. Then that first energy level has only 1 atomic orbital, which is 1s. While second energy level has 2 atomic orbital, which is s and p. So that's why we have 1s2. Now the first energy level is filled up. We go to second energy level, we have 2s2. Then the remaining 2 electron goes to 2p. So this is how we fill electron in carbon. Remember, the atomic number is 6, meaning it has 6 electrons. No energy. Now, remember what we are trying to talk about. We are talking about the chemistry of carbon. So how does carbon bond with itself? What is the bonding capacity of carbon? We can only determine the bonding capacity of carbon via the electronic configuration. That's what we call hybridization. Let's continue. Now, s orbital. This s orbital is very spherical in shape. And around the sphere is where electron resides. Why at the middle of that space where we have the nucleus? S has 1 atomic orbital because each atomic orbital has 2 electrons in it. Atomic orbital is 1, electron is 2. So when I have
don't close that door. Come and go and buy this for me.
Jesus,
come and go and buy one. I'm in class.
Please mute, please, I beg. Whenever you enter the class, please, it is expected of you that you mute yourself so that you don't distract others. So like I said, s orbital has 2 electrons, maximum of 2 electrons. So in each of these electrons are arranged in opposite spin, meaning that these 2 electrons that are not going to face the same side. One will be facing up, the other one will face down. Okay? Then p orbitals, which is dumbbell shape. We know what is dumbbell shape. Guys that normally carry weights. You know what is dumbbell shape. So that's the shape of p orbitals. And these p orbitals has 3 degenerate orbitals, which are the x, y, and z. And each of those 3 have equal energy. Now we have 3. I said they are all of equal energy and they have equal distance. That's why they are degenerate. They are twins. X, Y, and Z. Now, remember we talk about that in organic chemistry, our interest cannot go beyond s and p orbitals. So we're going to do with spherical orbital of s and dumbbell shaped orbital of p. Why are s have only 1 atomic orbital, p has 3 atomic orbitals. Don't forget. Okay. Now, before we talk about hybridization, we'll understand what is valency. Valency is defined as number of unpaired electrons of an atom, which can also be defined as combining power. Now, this unpaired electron are that electron that is available for to donate. Okay, and when it's deficient, that is the same one that either you release or you accept to commit. So the number of unpaired electron of an atom is called valency. That will be defined as a combining power of an atom. I've given you 2 definitions of valency. The first definition is unpaired electron. So when you say compound, take the unpaired electron. Now, look at this carbon. For a compound, for an atom to interact or react, they cannot be in their ground state. They have to be in a excited state. In ground state, everybody is on their own. In excited state, there's a reaction. So that's what happened when you are in a party. Everybody is excited, you're interacting. And in a burial ground, when you're going to on their own, no reaction, nobody wants. The only reaction that starts is when people start crying. So reaction can be positive or negative. What I'm trying to say is that atoms on their ground state does not interact. They don't react. And for them to react, they have to be excited. Now, when you're excited, you can easily give up things. In fact, everybody becomes your enemy. So this carbon in a ground state, remember, my s orbital is 2 electrons. My p is 3 electrons. Now, and I have 3 degenerate orbital of p. I have px, I have py, and I have pz. So for me to share this electron, I have to do them singly before pairing. So on my s, 1s is only 2 electrons and 1 orbital. I'll put up, I'll put down. In my 2s, the same. So when I go to 2p, what do I do? Then in my 2p, because I have 2 electrons and I have 3 degenerate orbitals. So what I do, I put first to x, then give y. Because there is none to give z, I'm not giving z anything. So this is what happened. Their original states, what people have. But they cannot go out like this because P is their friend. So P does not have anything to go with. And remember, 2S and 2P, they are friends. They are the one that are friends. 1S is their younger brother. So younger brother is not supposed to go out with them because they are not mates. It's only 2S and 2P are mates that can go. Then but 2P said, well, I cannot go now because I don't have anything to go with. But 2S said, since you are friends, what are friends for? I have 2 and I can share. That is what happened in a excited state. So 2S has to let go of 1 electron so that 2PZ will also have 1. So every of them are okay. They can go out together because they're on the same page. So that is what happened in a excited state. Now, whenever a bonding is happening, remember 1S is their younger brother that cannot go. So 1S cannot react with them, cannot form bonding. So S and 2P that are reacting with 2P and 2S. Now, count the number of electrons in that 2P and 2S. Remember, we have 1, 2, 3, 4. We have 4 electrons. And that is why, and all these electrons are not paired, they are unpaired. And remember we said that valency is number of unpaired electrons. That is why the valency of carbon is 4. Because carbon in excited state have 4 unpaired electrons. And that is why carbon is tetravalent, because 4 is tetra. Now, and that is also why whenever you want to draw a compound that has to do with carbon, the valency of 4 must be maintained. Remember, apart from number of unpaired electrons, valency is a combining power. Meaning that for carbon to bond with any atom, the valency of 4 must be maintained. It can be in single bond, it can be in double, it can be in triple bond, but that valency of 4 must be maintained. So at this junction, is there any question?
No, ma.
Okay, let's continue.
No. All right.
Now we come to the main, what is it, even this bonding we are talking about? Bonding in carbon is what we call hybridization. Now, remember, we have atomic orbitals S, P, D, F. But in organic chemistry, our interest is mainly S and P. So by the word hybridization, we simply talk about mixing of these atomic orbitals. When my S and P mix to form a single orbital, we call it hybridization. Okay, let's talk. Remember, they must be on the same energy level. So hybridization is a mixing of 2 or more. Okay, remember, it takes 2 to tango. So one thing cannot mix. There must be either a solvent or a solute for us talk about mixing. Okay, or 2 solids can also mix together. So it takes 2 to tango. So hybridization is a mixing of 2 or more atomic orbitals of the same energy level to form a new hybrid orbital. Now, 2 or more. In this case, we are using 2, S and P. And they are on energy level 2. And they are going to form another hybrid. That is SP. It can be SP3, it can be SP2, it can be SP. Whatever that is going to be formed will determine the nature of the compound. I say it again. Hybridization is a mixing of 2 or more atomic orbitals of the same energy level to form a new hybrid orbital. Now, when I'm talking about alkane, we're talking about saturated compound. Sorry, that was reflection from the house. Now, let's talk about alkane. Remember, I have to go back to the previous slide. Now, if you look at in excited state, we have 2x1, 2p1, 2px1, 2py1, 2pz1. In this particular excited state, remember it is only 2s and 2p that is bonding. This valency of 4 is what we see in saturated organic compound, a typical example of alkane. Where all the 2s, where the 2s and 2p all are involved in bonding. A typical example is your methane. Methane is CH4, meaning that I will add 1 hydrogen on 2s1. Remember, they are unpaired, so hydrogen is going to make them complete. An orbital is complete by 2 electrons. So all these ones are all unpaired. They need 1, 1, 1. So hydrogen will come and fix 1, 1, 1 on them, making it 4 hydrogen. That is why all alkanes are CH4. All alkanes has 4 bonding sites, saturated. There is no double bond because all of them, there is one hydrogen, making it typical example of is methane, CH4. Okay, so that's why we have sp3 because S is 1 and I have 3p. So we have sp3, and that's what we have here in our alkane, being sp3, making it number how many sites? 4 bonding sites, and all of them are single. That's what we call them saturated compound. When something is saturated, it means that there is no space. So when a compound is saturated, it means that this compound, there is no space. You're living in one room. You alone. Anybody coming, we know that there is no space. There is only one room. The person is coming to squat, and the person cannot be comfortable. Unlike when you're living in a 2-bedroom flat and it's only you, you cannot occupy more than one. So there is space. So there is unsaturation. That space is called unsaturation. Okay, because you still have space. Then when the same you're living in 3-bedroom flat, you have 2 space that is not used. So you're highly unsaturated. So saturation is that when there is no space, when a compound is saturated, it means that it cannot accept more. It's further. Yoruba, I don't know how they can't do anything. Okay, thank you. I have a Balasa phone that have 2 SIM. If I put MTN and 9 Mobile, there's no space again, it's saturated. If I want to do anything, I'll do SIM swap. I'll remove one for another. That's saturation. But I have dual SIM and I only have MTN. It means I'm unsaturated, meaning that I still have space to feel something. That's unsaturation. So the more the space, the higher the unsaturation. Unsaturation can also be likened to hunger. Remember, whenever you're fasting, you start imagining all the 1001 food you're going to eat. Because at that moment, psychologically, you're unsaturated. But just finish that fasting and start eating. Before you can't even finish one of all the meal you plan to eat, you'll be tired. Okay? So that eating, before you eat, you're highly unsaturated. You want to eat the word. But when you started eating, you realize that you became saturated fast. So I want us to understand saturation and unsaturation. Then having said that, we have agreed that all our alkane, they are going to make use of all the s orbital 2s1, 2px1, 2py1, and 2pz1 in bonding. So that's why they are sp and 2. Okay, sp and 3. So let's go to alkane. Now, if you look at the slide, you can realize that alkane, the A is in red. Alkene, E is in red, alkyne. So that A is the one made alkane saturated. E is what makes alkane to be unsaturated. Y is what makes alkyne to be highly unsaturated. So let's go back to the previous slide. We are still talking about excited states. Now look at when I want to form my double bond. Remember, for saturated compound, we gave a typical example of methane, where it is only 1 carbon. But whenever you're giving the example of unsaturation, like in alkane, you cannot use 1 carbon because it takes 2 to form a bond. So in that case, what we need is minimum of 2 carbon in alkane. When we start a homologous series, you'll understand why alkane starts with carbon number 1, alkane starts with carbon number 2. That is what we're explaining here, because it takes 2 to form a bond. Now, each of the carbon in alkane is going to donate 2pz electron, because they're going to use it to create space. Unlike alkane, that does not want anybody in the house. He just rented 4-bedroom flat and he has 4 siblings. Everybody have their room, so no space. king came and said, since we have 4 and we are 4, I think we can just let one room for visitors. Okay, let's allow one room for visitors. So this one donates one room, the key. This one, another person said, okay, it's fine. Let's let it go. So 2 people left from the same place. They created a space. That space is that, okay, this room, we're not using it, is space. And that is why in our king, we have S and P, 2. My P is 2 because the last P, I've used it to secure a space for somebody, making it unsaturated. There is space in the house. Now, that's why the hybridization is sp2. Why the one of saturated is sp3. Now, we'll go further in alkyne, highly unsaturated. In this alkyne, the electron in py and pz are being used in bonding. It means that in that case, if my Z can give me 1 bond, Y can also give me another bond, making it 2 double bonds. So that's why in alkyne, we have a highly unsaturated, we have triple bond. Remember, there is 1 bond that is normal bond, that is sigma bond. That's what bond, the bond carbon used to eat. But this one is additional bonding, which hybridization is going to give us, depending on the nature of the compound. In that case, my sp3 is for saturated alkanes. sp2 is for unsaturated alkanes. While alkynes are sp because they're highly saturated. They are highly unsaturated. Now, there's something we call P character. P character is that each of these hybridization has 100. So if I want to talk about P character of alkyne, because it's S and P, it will be 50-50. Because 100 divided by 2, I'm going to have 50. You talk about alkenes, the X character, can realize that if I divide 100 by 3, I'm going to have 33.33. So it means that they're not going to be equal. Now, if I come also to alkane, because 100 divided by 4, I'm going to have 25. Meaning my S character is 25, while my P character is 75, because P is 3. So that is S and P character when you're talking about hybridization. Any question on this? Any question? Ask your question. Should we go ahead?
There's no question, ma. There's no question.
Thank you. Let somebody always bail us out. Okay. So we are done with our hybridization. We have talked about what is carbon. We've talked about what is catenation. We also talk about atomic orbitals that we have in chemistry and the one we use organic chemistry. Now we talk about empirical formula. Okay. When something, I don't know whether you've had something is empirical. When something you're talking about empirical, you're talking about ratio. I can say, what is the ratio of male and female in your class? This is simply empirical. Then when I say, what is the actual number of male and female in your class? I'm going molecular. So empirical formula expresses the simplest ratio of atoms of the elements in a molecule of a compound. Every compound has how they combine. That ratio may be like in water, I have hydrogen, 2 and 1 oxygen. So if I want to talk about water and ratio, I will say 2:1. That two is one is their ratio, which is their empirical formula. Now, if I talk about molecular formula, assuming I have water, assuming I have a compound. Right. Jesus help me.
Who was on fire?
I'm always distracted.
There's nothing on fire right now.
Jesus help me.
Make that person mute now. A lecturer is on board. Mute yourself.
I think in the next class, course rep, I'm going to make a co-host. So as soon as they want to start making noise, you just mute them.
Please, I think the person unmuted is Folabi Oluwatomilola.
I'm going to mute them myself. Mute all. Just because the class is ending by 9:30. Because even as I'm talking now, I'm even feeling sleepy already. But God will help us. If there is time weekend, I wouldn't mind us using Saturday, maybe around 10, 11. I like morning class because that's when energy is at peak. After I'm drained the whole day, having this evening class I don't like it. Except when I don't have much in the day. But Tuesday is a very long day for me. Okay, let's continue. Empirical formula, I say, is the simplest ratio of atoms. I don't want you to cram it. I have a compound. And this compound contains atoms. So the simplest ratio of these atoms in this compound is what they call empirical formula. If I have like carbohydrates, it's made up of carbon, hydrogen, and oxygen. Empirical formula can say their ratio is 2:1:1. Empirical molecular formula will tell you that in total, carbon is 24, hydrogen is 12, oxygen is 6. Then this is their actual number. The other one is their ratio. So how do I get ratio from actual? You multiply by whatever you're divided. Now, if my ratio is 1:2, okay, and at the end, what I have is, I think we should know how to do ratio. The ratio I have is 1:2. Okay, when we get the calculation, we're going to understand this. Let me not go ahead of you. So molecular formula is the action number. From my action number, I can get their ratio. Okay. Then the structural formula. Remember I said that carbon bonds with tetravalent, 4 bonding sites. So whenever I want to talk about the structural formula of a compound, I'm going to show how this carbon is connected to oxygen or how it's connected to hydrogen, in maintaining each of the atoms' valency. Each of the valency of the element must be maintained when I'm talking about structure. So whenever I see oxygen, I know that my oxygen is divalent because oxygen has 2 electrons. Okay, now whenever combine with divalent, meaning that there must be double bond connecting to oxygen. That double bond must be connected once, or it can be also linked. If it's terminal, it can be two, like the double bond will be at the terminal. If it's in the middle, we have one bond by the side and the other bond in the by left and right, one bond. I think we understand this more when we are dealing with structure. I will explain it further. We understand what is structural formula. So if they said write the structure of a compound, it means that I want to show you that this is oxygen because valency of 2 is maintained. This is carbon because valency of 4 is maintained. All the compound and the way they link with each other is what we call structural formula. I hope that's clear. Ratio is empirical, actual is molecular, while a mode of linkage is the structural formula. This is a typical example. In an organic compound, on analysis, this compound was shown to have 40 carbon and 6.7 hydrogen. What is the empirical formula? Remember, empirical formula is talking about ratio. So whenever you're talking about any compound, organic compound, they did not say hydrocarbon. So we talk about they gave us carbon, they gave us hydrogen. So anything, whenever you know that the percentage they gave is not up to 100, so subtract from 100, the remaining one becomes oxygen automatically because we're talking about organic compound. So that's how we got 53.3 for oxygen. Then the second thing first thing you're going to do after writing out this is to use their atomic number to divide them. Okay, so that's why. Sorry, we're going to use the atomic mass, not atomic number. So that's why we're using 12 for carbon, 1 for hydrogen, 16 for oxygen. Remember, atomic number of oxygen is 8. The atomic mass is 16. Then after doing the division, I have to continue to divide until they are in their simplest ratio. Simplest ratio means that they cannot be divided again. You can't divide 1. You cannot divide 2 again. If you divide 2 again, well, you still get 1. So nothing can divide 2 except itself. And if you divide 2 here, we're going to have 1 to be 0.5. So at this level, this is the simplest ratio. And that is the empirical formula. Remember, carbon, hydrogen, and oxygen. So when oxygen is not given, and you're giving carbon and hydrogen, anything remaining from 100% is oxygen automatically. So divide by their atomic mass until you get a simple ratio. That is the molecular formula. Then if I want to do that's the empirical formula. If I want to talk about molecular formula, then after getting my empirical formula, I will equate it with either atomic mass or the molecular. Okay, so I'm supposed to this formula. Oxygen have 2, oxygen have 1. So that's how we came about it. Then this one, I want to know what is the actual number of this carbon, hydrogen, and oxygen in this compound. Then before you solve molecular formula, you're going to be given an atomic mass of the compound. So from there, you're going to substitute. Okay. Now, N, it means that if I take my atomic number and my empirical formula, I'll bracket it and put N. N is that a multiplier, a factor that will multiply to get the molecular formula. That's why they say N is equals to molar mass divided by empirical formula mass. How do I get the empirical formula mass? Remember, we're dealing with carbon, 2 hydrogen, and 1 oxygen. Carbon is 12 by atomic mass. Hydrogen is 1 times 2. Oxygen is 16, giving us a total of 13. Okay? And now you've been given that the atomic mass or molecular atomic mass, okay, of this compound is 16. Meaning N is equals to, or molar mass. N is equals to atomic mass or molar mass divided by empirical formula. Now I will have 60 divided by 30, I will have 2. 2 is that factor that will change my empirical formula to become molecular formula. That's why we have C2H4O2. So this is the molecular formula of this compound. Remember, I cannot get molecular formula without getting empirical formula. So there's no empirical formula without knowing the percentage of the compound you're dealing with. Like percentage, like now, we said, okay, there's 100,000 to share. And we're going to share it according to how first come, first serve. The first people is going to get 80%, second will get 60%. Now the percentage that I'll give 60%. And 60% we're dealing with 1% of putting the actual number of what that system means in the box. about molecular formula. That thing was repeated. So this, I'm going to end the class at this stage because I want to give you the best. As I'm talking now, my eyes are closing. Okay, let's stop in isomerism. So let me talk about this ones. Now, functional group in organic chemistry. Functional group is that aspect of a compound that determines the reactivity of this compound, the identity of the compound. In a normal world, when you see a girl that is matured girl, the only way you can know this lady is look at the ear. Even if the person is not busted, look at the ear, and times look at the hair. Not these days where even the guys will not allow ladies to make hair again. And then they make it, and then they wear earrings, wear necklace. So you can see a guy, you see the guy will look like a female. But normally, the functional group of a lady is just look at the ear, or look at the chest, or look at the hair. So that's what made the person a lady, not word of now. So functional group is that aspect of that compound, is a metal or group of metals that define the character of this compound, especially the reactivity or the reactions it can undergo. So number one is alkane. Alkane are saturated hydrocarbons. By saturated, they are bonding with the 4 sites that we have in carbon. Example of them are methane. I told you when carbon is 1, a loner. Then ethane, propane, butane, and pentane. We have even to 20. Now, when alkane, remember the molecular formula for alkane is CnH2n plus 2. Now, when I take away 1 hydrogen from that plus 2, it becomes CnH2n plus 1. That CnH2n plus 1 is alkyl. Alkyl is alkane that loses 1 hydrogen, becomes alkyl. That's shown on this slide. You can see from methane will lose hydrogen and become methyl. Ethane will lose 1 hydrogen and become ethyl. So these are substituents and how they are formed in organic chemistry. So these are the common functional group that we have. Alkane is a functional group that determines saturation. Alkane determines unsaturation. Alkyne shows highly unsaturated. Then we have alcohol, which can also be called alkanol, which is hydroxy functional group. We have carboxylic acid. We have ester. We have ether. Ether is when there is oxygen in between the 2 metals or 2 substituents. We call them ether. That's why I say ROR. Okay. We have amine. Amine is a derivative of ammonia. Okay. When ammonia loses hydrogen, becomes amine. We have amide. Amide is when there is exchange of hydroxy group of a carboxylic acid with amine. We form amide. And we have alkanone. Aldehyde and alkanone are the same thing. Aldehyde and alkanone are the same thing. They have something in common. They have carbonyl in common. Why aldehyde is more acidic, alkanone is less acidic. So that's it about the slide. Finally, on this note, we are going to talk about homologous series. Homologous series is your family tree. Let me explain the family tree. In your family tree, you talk about first son is 2 years older than second son. Second son is my mother normally spaces by 2 years. That is how their own change in degradation in the homologous series. So your name that normally ring bell, and whenever I'm talking about Bianco Juku, everybody turn around. That is the homologous series. And any individual in terms of in that family is called a child. That is called homolog. But the family is homologous series. Now, in homologous series, a compound or a group of molecule, the member differ by CH2. That's why I talk about 2 3 years interval, okay, in a family. So they differ by CH2 from one another, usually methylene. Okay, they have the same physical properties and similar chemical properties. They cannot have the same, they will have similar, but they have the same physical properties. That's homologous. Okay, that's why in the family, since this person, the character is different, say, this will not be something will come from your family, because the attitude does not correlate with what happens in that family. So each member of this family is called a homologue, but the family itself is called a homologous series. Homologous series is a family name for these people. Okay, so ask question now, because we're going to start on isomerism. I'm going to share this slide so you can make out time to go through it. So next class will not be this stressful. Ask your question. Because there are people that need to be bailed.
Ma?
Bail them, or some people will not ask questions. Even if you beat them, they will not ask questions.
Okay, please, if you have any question, raise your hand up, please.
If there's no question, because as I speak here, my eyes are closing.
I have one question.
Okay.
Looking at the, I think, Ma, there should be a practical example in that SPDF, the orbitals that you gave. Is there anything like electronic configuration in this course? Because I came across it one certain time, that when we are taking organic chemistry, they also teach along electronic configuration of some elements, something like that.
Now, electronic configuration of elements, you're going to learn it in the inorganic man is going to teach you electronic configuration.
Okay.
Because yes, that's his part. Normally, that's why I said that it's supposed to teach before start, so that I can prepare the ground. So that's the essence of that. So you're going to teach you that, because electronic configuration is virtually an inorganic section. That's why in organic chemistry we deal with that electronic configuration of carbon. Okay, then valency of other atoms, because we don't need their what we need is their valency. That will help them to form bond, and mainly oxygen, nitrogen, and halogens, and at times phosphorus, and many things you're going to see in this organic chemistry. Okay, so we are not dealing with most of the metals. At times magnesium when you're dealing with binary reagents. So you're going to learn about electronic configuration in inorganic section. But if there's any question you have in electronic configuration, I can put it down. I think in the next class, if it's something that this class takes place in the bright day, I would have projected this and use a board to teach you some things. So I don't know the schedule, but let's continue what we're doing. You're going to understand it better. If you're doing electronic configuration, what you need to do when you get the atomic number of a compound, you start with 1s2. After the first energy level just have only 1s, does not have p. Second energy level has p and s. So you have to fill s before filling p. Remember that s has 2 electrons and p has 4 electrons. So assuming I'm dealing with a compound that is like 15, that's a chlorine. So I can do 1s2, 2s2, okay, 2p6. So now I have 10 already. Then 3, I'm done with pure s orbital of energy level 2. I'll go to energy level 3. 2s2, making it 12. Then the remaining one is in p. So I put 3p5, making it complete for what I'm looking for. So that's how it's done, level by level, but you'll be taught, because it's a section of inorganic. Any other question?
Yes, with respect to empirical, molecular, and structural formula, I just want the example of looking at carbohydrates, wherein you have CnH2nOn, and supposedly that is a kind of a molecular formula. So, if, for example, we take glucose, which is C6, H12, and O6 to be the molecular formula, how can we get the empirical formula for such?
Now, from the molecular formula, you can actually predict the empirical formula, because empirical formula is ratio. Now, if my molecular formula is C6, H12, O6, simply divide by 6. I have 6 divided by 6 is 1.
1 to 1.
12. So 1 to 1.
Okay, so it's going to be 1 to 1.
Yes.
Okay, thank you.
So it's always easier to get molecular empirical from molecular, but you cannot get molecular from empirical, except there is a molar mass that you're going to substitute. You understand, to get N. The factor of N, yeah.
Thank you.
Welcome. Any other question? Okay, so cost step, I'm going to share this slide with you. Okay, so that everybody can go through it. Please make sure that after each class, you make out time to go through all that was taught, because at that moment, those things are fresh in your brain. You can relate. Okay. And this this particular class is being recorded on YouTube. I have a YouTube channel that treats organic chemistry. So everything that we've done, so we are going to do is taught in detail, because in STEM we're not going in much detail. The only detail we are going to go is just for you to know the basis, because the essence of the course is for you to know the basis of organic chemistry. But if you are a chemistry lover, all the efficos I saw that read chemistry, go to the Dr. Anita Chem YouTube channel, so you can watch anything you want to watch on chemistry. And you can also ask questions to me on private chat or on the YouTube. Okay? It will help you, especially those that want to do education in chemistry. Make sure you understand some chemistry. Okay? Use this opportunity. Just don't read. At this level, you're not reading because you want to pass. You're reading because you want to impact. So the way you approach your studies now will be different. So I wish us the best. Okay? And my prayer is that at the end of this course, at least when they're talking about chemistry, you're going to smile with good A. But that's my joy. Okay, thank you very much for coming.
Thank you very much, ma. We'll
So
surely check the channel. Thank you very much, ma. Yes, ma.
Thank you very much.
Thank you, ma, for the class.
Thank
We are grateful.
Thank you. All right. Good night, everyone.
Good night.
Good night, ma.